Good morning. Good morning, everybody. So let's wait a while till people join in. And I do know that you may have a lot of questions related to midterm. I will come to that. So uh, don't worry. We'll go through it slowly. Yeah. Nothing to, panic. There is enough time to prepare for your final also. So we will get all of these things sorted out. So let me just make some announcements. So nothing major. So the original plan for this week was to go into more statistics, talk about things like hypothesis testing, which is based on central limit theorem. But then I thought perhaps it will be more useful if we cover simulations more properly. I think that will be useful for you when you do your higher courses and things like that. Okay, so anyway, it is not difficult. You have learned Python programming. This will also be breeze. So let me just tell you few pointers how we should do this. We will use midterm questions as a reference. Okay, and yeah, let's just wait because there is still time. So what we will do today is like go over all the typical midterm mistakes that you have done, and this is mainly in the programming. Everybody has done very well in the theory, more or less. Okay, even those who got low marks, even they have understood the concepts well. So nobody has made any blunders. So what we will do is we will go through the programming things, and if any one of you feels like you haven't got enough marks, please let me know, and we will discuss properly all your midterm questions. Okay, it is possible that I might have been a little strict. It's possible, but be prepared because I know that a few of you have copied. So in order to be fair, so that the student who has copied does not get away with it, I will also be doing some investigation. But those of you who approach for discussing the midterm, I will uh, I will definitely help you, but you will have to explain your answers to me whenever I ask. So I will try to find out if that's your original answer. Okay, so everybody, that's the protocol that we will follow. Yeah. So, and yeah, so this is a large class. I knew it will happen because all of you are smart guys. So you will, if you feel like you can get better marks, why not? You will do things like that. But the big picture is you are in the careers of CSE and math and computing. And even though you may get a few extra marks by cheating now, it will actually affect your career because you will not be good at what you have certificate for. Okay, so it will affect you, because you should be able to do what your marks show. So if your marks is high, you should be able to show that you can do what your marks claims to do, say, right? So that is what I'm saying. Anyway, all those things aside, so I think there are a good amount of people here, so let's begin. So before that, if anyone wants to say something, anything, you can ask me now.
Sir, there will be a quiz tomorrow.
There will be a quiz tomorrow. The quiz portions will be as before. So whatever was announced. So that's what. So this in this class, these two classes, I was supposed to teach different things, but I thought that it will be better to address the. There is only one deficiency that I saw. There is people are not doing programming well, but no problem. So we will discuss it in detail. It is a you have enough time if you practice half an hour per day. You should be through. There will be no problem because you have understood the concepts. So programming is not that difficult, but you need to practice. So that is the only thing that you need to do. So I will give you some tips so that it helps. Okay, so that's what we are going to do. So Siddhant, the quiz is I will announce again, but I have made a classroom announcement. So basically, Markov chains 1 and 2 videos. Either you can watch mine or you can watch Sitsikilisis. Then you will have estimation, whatever was taught last week. And then you will also have a weak law of large number and central limit theorem, these concepts, probability inequalities. These are the things that was discussed. So between this quiz and the previous quiz. So those things are there. So you will find it in the Google Classroom announcements. So yeah, if you are not able to find, you can ask the TS and we will tell you. Okay. Yeah, I'm sure all of you are a little worried about your midterm marks, and we will deal with that. Particularly programming, you may not be understanding why you might have got a 0 or things like that. Okay, but not to worry. I think your fundamentals are good. So I think the course has achieved its objectives. Just the midterm programming parts, you might be having some difficulty, but we will fix it. Okay, so did I speak the entire thing with mute?
No, sir.
Okay, good.
No, sir. You are audible then.
Audible,
Okay.
sir. Audible.
Yeah. Thank you. So let's discuss some programming. All right. So let's start. Let me just pick up the midterm question. Before that, can one of you who is in CS, can you tell me what is the first exam that you have? Date of first exam?
Sir, till now it is announced that on 16th we have discrete mathematics.
Okay, 16th December, discrete maths. Okay. So tomorrow will be and for MNC math and computing, what is your first exam? Satvik is there?
Sir, only the 16th on 16th discrete mathematics is announced for CS and MNC guys.
Okay.
Math specific have not been announced yet.
Okay. And for the master students, what's the earliest thing that you have?
So for a mechanical side, I've got a paper on 15th.
Okay, all right. Okay, thanks everyone. So that's. I just wanted to know. Yeah. So tomorrow will be the last class, but I will hold meetings for those of you who may have questions. I will announce some times where you can join in the meeting and ask your questions. All right. So that way we will try to learn these things. So I will do that sometime next week. So I know these are the slots that you are having your first exam. So before that, we will keep a few 1 hour discussion meetings if required. So let me do that. And you can come in and with your questions and we can go through. Anything is okay, programming or whatever. Okay, so we will do that. All right. So Let's start. So let me share my screen. Okay, the first question was, there were two questions midterm. So question number 1, this was memoryless. Okay, so memoryless of geometric. This was, yeah. This was the question that was we were looking at. So this was the first question. What you had to show was using simulation. You needed to show what is the PDF of. Basically, what you needed to show is that x minus 3 given x greater than c3, the PDF of this. Okay, so the PDF is like geometric. Okay, so this was the question. So this was the first question. See, the idea here is that you should first simulate geometric. So what that means is you have to get samples of geometric. So what is a geometric random variable? Can someone tell me?
That till
False success.
Yeah, you repeatedly do a coin toss till you get the first success. Okay, and you are basically, what you are doing is you are asking the computer to do the tosses for you. All right, sorry about this. I will just switch off. Okay, so what I'm saying is you're supposed to do a coin toss. What you're asking the computer is actually to do the coin tosses. Okay, and the CPU, there will be, if you want, you can picture some kind of a machine actually doing the coin tosses for you, and it will report how many times did it take to get the first head. Okay, so that is what it is going to do. So what you need to tell the CPU is what is the bias, what is the probability with which you will get a head. Okay, so that is what you need to tell the CPU. So what you need to do, for example, is here. So all these packages that you have, all these random functions and everything is built in a package called as NumPy. So you are first importing this. Okay, and you're going to ask np.random. Okay, that's all the random variables are there. In that, you will ask for geometric. Okay, and if you put, it will show you what probability it is asking. Okay, so I can give, for example, something like 0.9. Okay, then it is asking how many times should I repeat the experiment, which means do you want one geometric sample or 2 or 3 or so on. Okay, so if I run this, what do you expect? Can someone tell? What number do you expect? So basically here, no, it is going to do, the CPU will start doing a coin toss with a coin whose bias is 0.9. Okay, and it will repeatedly do the toss till it gets first head. And the 1 indicates I'm going to do this entire sequence only once. Okay, since the bias of the coin is very high, you will expect the number to be 1 immediately. So in one trial itself, you got the answer. Okay, now if I reduce this number and say if I make it 0.01, how many do you think it should be? It will take much more time, right? So this will be close to 50. It had to do 50 tosses before it got a head. Okay, so does everybody understand how this geometric function is doing?
what is one doing, sir? Like, what is the role of one here?
One, basically, it is going to do one sequence of toss till it gets head. So imagine there is a person sitting, you are going to give him a coin with probability 0.01. That person is going to keep tossing till he gets a head, and he will do this exercise only once. Okay, and he will tell you how many times it took till you got the first head.
So if we enter 2 over here, then we'll be getting 2 arrays, 2 separate arrays.
Yes, exactly.
Okay, sir.
Do you see this? It gives you 2 separate arrays.
Thank you, sir.
All right. So now this is what you should be using. Okay. Whenever I say simulate, you are supposed to get samples from this package. So there are two alternatives. Either you can use NumPy, or there is another one which is equivalent, which is called as SciPy. Okay, either of the two you can import, and there are things. So whenever you have a question like how to simulate, you just go to Google. Google is your best teacher, and ask simulate Bernoulli, right? Bernoulli in Python. Okay, and then when you see there are plenty of examples, SciPy example is there, NumPy example is there. You can check either one of them. There is a Stack Overflow also tells you what to do. Okay, so this is the SciPy example. It tells you everything what you need to do. Okay, so this NumPy is also telling you how to do this. So there are all these things that are there. In my exam, I did not say you should not look at internet. You are free to look at internet to get help on how to do things, but don't directly look for solutions. Okay, so that's all I said anyway. So yeah, anyway, coming back to the problem. So this is what, how do you get samples from geometric? All right. So now, if you see, this is where I have used here. Okay. So this one is going to generate like reps sample repetitions, that many samples with the bias P. Okay. And the samples will be simply returned. So this is where it comes. Okay. And this is the first part. So this, I hope till here everybody understands what's going on. Okay. So till here. So if I execute till here, so you select, and if you execute till there, you will see that there will be 10,000 samples in samples 1. These are all the samples with the bias 0.2. Now, what we are interested to do is, now we have to do this thing. So you are supposed to simulate x minus 3 given x is greater than 3. Okay, so this is what you are supposed to do the samples next. Okay, so what you are going to do is you are going to sample. So what is the steps? So the first is sample geometric random variable. You'll get many samples. Second, discard samples where x is greater than 3. This is step number 2. Third one is subtract 3 because you want x minus 3. Okay, so this is the way in which you can simulate samples from x minus 3 given x is greater than 3. Is this all right? So let us see how it is done in code. So what you do is you first sample as it is. This is step number 1. Okay. Then this is the way in which you discard samples. So I'm going to discard all samples where samples is less than or equal to k. So let us show that with a simple example. So let us say A is a NumPy array. Okay, with 1, 2, 3, 4, 5. Okay. Now from A, I would like to discard all the things where A is less than 2. So which are all the things where A is less than 2, less than or equal to 2? So you can see that it is first 2, right? Is where it is less than or equal to 2. So I want to discard it. So what I will do is I will say A is equal to A, where only take those A's where A is greater than 2. Now if you see A, it has only 3, 4, 5. Does everybody follow this? Okay, so this is step number 2. What we did is we discarded all the samples where the value was greater than 3. Sorry, value was less than or equal to 3. So discard samples, and yeah, nobody corrected me. Please correct me whenever I make this mistakes like this. Discard sample where x is less than or equal to 2. So this is not correct. Okay, so that's what we did, right? So we only took samples where samples was greater than k. So let us write this help. Take samples where samples is greater than k. Only take samples where samples is greater than k. and then you subtract k from it. Okay, that is why, because we wanted this, right? So that's what we did. And now this will give you samples where this conditional is true. Okay, so this is samples 1. This is where you are getting simulate x minus k given x is greater than k. All right. So now you have 2 samples. What you are going to do is you are going to estimate the PMF. Okay. So let us run till here and see what is the thing. So samples 2, if you see, okay, can someone tell? Yeah, samples 2 is here. So now how do we generate PMF from this? How do we generate?
So by counting frequencies and dividing by length.
Yes, so that is what we are doing here. So what we do is we take the samples in this, okay, and we are going through every element in the data, okay, and if there is a entry in the counter, so this is a dictionary. So if you remember, if you have forgotten what this is, it's called as a dictionary. Okay, so let me say how it works a little bit. Okay, so let's see how dictionary works. So counter. Okay, so now the dictionary currently is empty. Okay, now I want to count how many ones are there. Okay, so what I will say is I will first check if there is one is there in the dictionary. So I will ask if one in counter. Okay, if one is there in the count, if one not in counter means one is not there in the counter. Okay, I will say print one. Okay, so when I run this, what do you expect?
Sir,
Yes.
you need to do control enter, I guess.
No. I'm saying if I press enter, what do you expect? It will say one is not found because counter is empty. Okay, so let me introduce counter. So let me introduce some value here. Then if you see counter, it has 1 with respect to, so this is called a key, the first part, and there is a 4 here. So now if I run this, I will not get anything because there is actually 1 in the counter. Okay, so that is what I'm going to do. So this entire program is going to count for every element. If there is a number, how many number is there? If it is there, it will increment by 1. If it is not there before, it will make it 1, and then it will divide that total length of things and divide it by the length of data. Okay, see, I'll give you bunch of money. Okay, and what will you do to count it? Yes, how will you count if I give you money? You will first count how many 1 rupee coins are there, how many 5 rupees coins are there, how many 10 rupees coin are there. Like that you will count, right? The same thing we are going to do. We are going through every element in the data, and whenever you find some coin that you have not seen before, you will initialize it to 1. And if you have already seen 1 rupee coin before, you increment it. That's all this entire thing is doing. Okay, so this will count how many times in the data you are actually seeing a particular value. Okay, and then it will divide it by the total length of data, and that will give you an estimate of PMF. Okay, so that's it, and then you will plot the bar chart of the keys and values. So this is what is the entire program doing, and if you run it, what you will expect is you will see the 2 things. Okay, so this is what you are supposed to do. Okay, so I haven't put any these things, but in the exam, I'm okay if you don't put, but whenever you do any research paper, you have to put x-axis, y-axis and all these things in the exam, but I have not done. But is it clear? Does everybody understand question number 1, what you need to do to get full marks? Yes, everybody fine with this? I will share the code with you.
Sir, can you just explain about that relative equal to true part?
Okay, so yeah, good question. So basically, Python has a feature which is called as default arguments. Okay, so what that means is if I don't give anything, it will automatically take the default argument as relative is equal to true. But if you want to override it, I have to specifically say false. Okay, so this is called as a default argument. Okay, so now when I call it first time, let me show what happens. So now you see the numbers are 2000, 1700 and all for the first case. Why is that? Because I did not do the normalization by dividing by the length of the data. Okay, because it took relative equal to false and this if condition was not executed. Is it okay? Whoever asked me this question?
Yes, sir.
Okay. So anybody has any other questions? Is this clear? So what you do is that I will give you all this code. You experiment with it. Okay. I've already shared the code for previous programming assignment. You just keep working with it. Okay. New programming assignment that I have given you, you just spend time on it. If you are not able to solve, come to one of the meetings where I will be there to help out with these things, and then we can solve it. Okay. So that's what we will do. All right. So now this is what was expected here. So if you have used if you have used the PMF and plotted that will not give you marks. I actually want you to generate geometric samples. All right. So this was question number 1. So now let us come to question number 2. Okay. So this is the thing for the Monty Hall problem. Okay. So now, so first thing in the Monty Hall problem is basically this is it's called. Let me write it here. So let's see. Question number 2, part 1. Okay, so you have essentially 5 doors. Okay, so these are 5 doors, and the doors I will call it from 0, 1, 2, 3, and 4. Okay, now first random thing what you need to do is randomly place the price, you know, the whatever, the car or whatever, you place that randomly. Okay, so now there are 5 choices which are equally likely, and what you are asked to do is to pick one of the 5 choices. Okay, and there is a function for this. It is called as np.random.choice. Okay, so now here you see it has several things. One is the elements itself. What are all the things that I am choosing between? Okay, so I can put, for instance, I can put let us say apple. Okay, and then I can put orange. Okay, I can put banana. All right, we can put like this. Okay, and if you see, size is a default argument, replace is a default argument, none is a default argument. What that means is I don't need to give anything. So if I don't give anything, what it will do is it will pick one out of the 3 choices randomly. So if I run again, it will give something else. So now it gave banana, sometimes it will give orange. Okay, so you can see. So these are all the ways in which you can choose one thing sort of the thing. What we are doing is we are having some doors. Okay, so we will first tell what are the doors. So if you see here, the code that I've shared, these are the doors. So I've called the doors 1, 2, 3, 4, 5, doesn't matter. So these are the doors. So now what I will do is I will ask you to randomly choose one of the doors. So that is going to be by this function. Okay, so that's one came. Sometimes it will 3 will come, 2 will come, 5 will come. So behind this, you will decide to place the price. So let's say price may be like a big bunch of 2000 rupees notes. So it could be like this. So this is what is the thing. So now there are other arguments that are there in the choice. So the first argument is what are you choosing from? So I'm going to choose from the doors. Second, I can ask, do I want to choose 1 item or 2 item or 3 item and so on. Okay. So if I say 2, I will get 2 choices. Okay. The first time when I chose, I got a 2. Second time when I chose, I got a 1. So like, for example, if I choose fruits, right, in that, if I say, give me 7 times, what it will do is it will choose one after the other. Okay, so that is what the size parameter tells. So now what else? There is a doors, then there is size. Okay, and replace. So what this replace says is once you do the experiment, right? The first time when you do, all the items are there. You choose an item. Second time when you are repeating it, do you want to redo the experiment with all the choices again available? Okay, so that replace is going to allow you to do the experiment again with all the items once more. So for instance, if I do replace equal to false, okay, what that will do is it will only so let's say I do it 3 times. There will be once it chooses the 4, the array will be 1, 2, 3, and 5. Then again it will choose from 1, 2, 3, and 5. It will choose 3 and so on. And finally, you can also tell what's the probability. Okay, so that is the P, last thing. So that is what is np.random.choice. So all these details you can get if you go and search for np random choice. If you search in internet, it will tell you more than enough things than what I have told. It will be here. A lot of these things, examples, everything will be there. Okay, so that is what we are doing here. So np.random.choice. Yeah.
Like in conditional probability, like if we have done this as false, so
Yeah.
once what is the probability of getting 3 once once 4 has been picked?
So yeah, so it will change. So originally it was 1/5, but once 4 has been picked, 3 will be 1/4.
Okay, sir.
Yeah. Okay. All right. So now we will run the simulation. So what we are going to do is this is the single sample thing. So we are going to first choose. So this CRR sample is door behind which there is price. Okay, this is the first sample. So I don't have to give this probability. Okay, so this is probability saying all of the things are equally likely. There is no necessity to give it, but I have given it. The second one is a player choice. This is the choice made by the player. Okay, so everybody is understanding so far. So now what you are done is I will run one simulation. Okay, so basically you have to think of this is like the computer is playing Monty Hall. Okay, it has got a contestant, it has got a game show host, and they are playing this game. So if the current sample, okay, if the sample that was chosen, the prize where the prize is there, and if the player has chosen the same thing, if the person switches, okay, then they will get no reward. Okay, but if it doesn't switch, the reward is 1. Is that clear why this is happening? So you will win if you use no switch strategy. Okay. Now suppose current sample is not equal to player sample. That means what does that mean? So that means the game show host will now show something else for you, right? So that even if game show host will anyway do that, but we are going to consider what happens when the game show host, how will he choose the other door? That is what we are trying to do. See, the first thing is game show host cannot show the price. Okay, so first thing what you do is you remove the door where the actual price is there. Okay, so this is to remove, this is the residue variable will contain all the doors where the price is not there. Okay, and the game show host cannot open the door which the player has chosen. Okay, so that's why we will remove that also. Game show host cannot show the player's choice. He cannot show that door, right? So that's why we will remove that also. Okay, now what is left? Can someone tell me what are the doors that are left? Ramnath, what are the doors that are left? Anybody?
Do we
See,
have a
the
given
first-
example or one the door which was first chosen that cannot be opened?
Yeah, the door. Yeah, exactly. The door that was chosen by the player.
first.
Yeah.
Yeah.
Yeah. So basically, all the goats are left, isn't it? only the goats are left. And if the player has also chosen a goat, that goat also will not be shown. Okay, so what this is going to do is, this is the choice. This is door chosen by game show host. Okay, and so this is what is done. Now player also has to. Okay, now this is done. Now basically the player has to decide among the remaining doors which one is he going to pick. Okay, so what he has to do is, he can actually choose. He can choose anything, but he cannot choose the sample that he has already chosen, and he cannot choose the sample that has been shown by the game show host. Okay, so player cannot choose the original sample. Okay, when he cannot choose original door, if he's switching. Okay, he cannot choose the original door if he's switching. So that is why we are doing this. So let me write this clearly. So player cannot choose the original door if he's switching, and he cannot choose the door which was shown in the second time, which was shown to him. So that's why we are removing his original door, and we are removing the door that was shown. Now he will choose one randomly out of this. Okay, and he picks that, and he will win. He will win when he chooses the prize. So that's it. So that is all we are doing here. Okay, so this CRR sample is the one where there is price. So this is one sample. Okay, and now basically we can do multiple samples, and then you can go through this code, but this is all easy. Okay, so when you run this, you will get the desired answer. Okay, so this is what you're supposed to do for the Monty Hall question. Yes, anybody has any questions here? Till the code runs, you can ask questions. All right, so the actual answer is, go ahead.
Sir, we already removed that price door as well, I think.
No, we removed it, but now we are starting afresh. Good question. So we are starting afresh. So this one, see what we have done is, we have removed from doors and put it in a residue. Okay, now we are again starting afresh from doors. Now all the doors are here. Does that make sense?
Yes, sir.
Yeah, good question. Okay, so basically the actual theoretical answer is 0.26. Okay, and 0.2. So that numbers you can see here. If you do more samples, it will be more smooth. And here again, you can see the center limit theorem in action, right? This is looking like a bell curve. Okay, and if you see, it is converging to 0.26 and 0.2. So does anyone have any questions here? I don't know if this is a useful thing that I'm doing. I am not sure what's going on. So let me just do a poll and see what people are saying. So so far, whatever I have taught, the first and the second, is it clear? Can I have a quick survey? So Siddhant, don't hesitate. If you feel like you have some question, ask me, because that may be common question everyone has. Okay, so don't hesitate. Everyone, if you have a question, just ask. All right, so good. So looks like many people have actually followed. All right, that's good. So now coming back to the example. So this was for midterm question with respect to the Monty Hall. So let us go to the birthday question. Okay, so let's discuss that question again. So basically that is called as a birthday paradox. Okay, so what is the big paradox? Let us first discuss that. See, there are 365 days in a year. Okay, 365 possible birthdays. Okay, let us say there is a class of size 23. Okay, so this class size is 23. It's a reasonably small size. Let us say our class that we are having here is of size 23. Now what I will do is I will ask each one of you what day you were born. Someone will say I was born on the first day. So see, we are all computer scientists, so the first day starts from 0. Okay, some other says okay it is 3, and someone says it is 360. Okay, so these are the days of the year, right? Assume that there is no leap year for simplicity. Okay, so like this we will choose. Okay, somebody will say 15 and say 88. I don't know, 233. All these things 23 people will say. Okay, now if you think about it, 23 is a very small number compared to 365. Okay, now the thing is, with 23 itself, there is more than half chance that 2 people have the same birthday. Okay, so probability that 2 people have shared birthday in a class size of 23 is greater than 0.5. It is surprising, right? You wouldn't expect it because 365 is such a big thing. 23 can be arranged in so many ways in 365. Even then, there is more than half chance that 2 people have the same birthday. Okay, so let us say we want to make our computer simulate this. So let us say the class size is 40. Okay, so now with whatever I have been teaching so far, you should be able to tell me how do I pick 40 birthdays out of 365? Siddhant, can you tell me how we can pick 40 day numbers from 365?
Yes, sir. We'll use NumPy random randint, and we'll set the limit to 0 to 364. And
okay. Yeah, so that he told randint, which I am not familiar with, but we can use that. But just to make things simple, Siddhant, I will, if you can tell me with the choice, I will be much happier. Can you tell me with the np.random.choice?
Okay, sir. We'll use np.random.choice, and we'll put the size equal to 23. And just 1 second, sir.
Yeah.
And for the choice, we'll put the range 0 to 365.
Yes. So that's what we will do. Okay. So this is first I will choose all the days. Okay. And then I will do np.random.choice. Very correct. Whatever you said is correct. So from these days, I will choose the size, which is n. And this will be my birthdays. BDs, birthdays. Okay. So let us see what we have done in the code actually. So np.random.choice. Okay. The array size, the class size. Replace is equal to true because I don't want, I mean, there is a possibility that I should be able to choose same birthday. So once somebody is born on January 5th, okay, you have to choose again January 5th. Okay, you cannot say January 5th is already taken. So that's why replace is equal to 2. You remember, right, this discussion on replace. Anyway, so these are the birthdays that we are having. So now you have the birthdays. Now basically, you have to find out if there were duplicates. That's the question. Okay, so duplicates in an array you would have done in your CS 101, but we will use some program to do it, some library to do it. So NumPy has a library called as unique. So let us see what it does. NumPy unique function. So if you see the library, it says first you have to give the array, okay, and then so this is given. So now what it returns, it gives you this array of unique values. Okay, so there are 2 things you can do. So let us try to do this, understand this. So let us say a is equal to 1, 1, 2, 2, 3, 3. Okay, so this is a. So I can say numpy dot unique of a. It will give me 1, 2, 3. Okay, so let us say b. I will say it's that unique things. So what I can do is I can compare length of a and then length of b. So if length of a and length of b are not unique, that means a had duplicates. This is one way. Second thing that you can do, you can ask unique to give you the counts of each of the unique elements. So that will be return counts. So this will give you return counts equal to true. That's what you need to give it. You are asking it to tell all the how many times each unique thing is appearing. So it says that the array has unique elements 1, 2, and 3, and each of them is appearing 2 times. Okay, so that is what it is doing. So you can store this in 2 arrays. So you can store it as unique values, and then you can say unique counts. Okay, so now if I print unique values and unique counts, you can see what are the things. Unique values, what are they? That is same as previous 1, 2, 3, and unique count is telling each of them how many times it appears. So it is 2, 2, 2. So does everybody understand how unique works? Okay, so now what I'm saying is I'm actually doing so basically I'm saying yeah, so this is a rather complicated way in which I have done. So what I'm saying is, first you pick all the elements where the count is greater than 1. Okay, and then you look at the sub array where the count is greater than 1, and then you look at the length of that. So this is more complicated. I don't know why I did this. There's a much simpler way. Perhaps we should do that. So let's not go with this. This is quite stupid. Okay, so let's do a simpler thing. So what we will say is unique birthdays. So this is np dot unique of birthdays, yeah? And then if length of birthdays is not equal to length of unique birthdays. Okay, so if this length is not equal, that means there is a duplicate. You just say duplicate found. So that's it. So this is what we are doing in the one sample, and essentially we are counting if I repeat this many, many times. Okay, so for example, how to understand that repetitions? Once I go to CS class, which there are 40 people, then I will go to math and computing class, which has 40 people. Then I will go to electrical class, which has 40 people. Then I will go to Goa Engineering College. Then I will do the same thing for every class there. So like that, I'm collecting different classes, and then I'm trying to find out how many times birthdays are repeating for a class size of 40. Okay, and then I'm plotting this. Essentially, that's all the program is. Okay, so now the class size is 40, and for 40, when you do this birthday thing, you are going to get an answer close to 0.89. So let's wait. So please ask me any questions till the program runs. If you have any questions, you can ask me now. Ramnath, is everything clear? Whatever we discussed?
Yes, sir. Yeah.
Sir, it's not regarding this code, but regarding the logic, the mathematical logic behind this.
Yes.
Like, since we are using random function, like it is not supposed to be a normal distribution or something of that sort, right? So
no. It is going to choose equally likely all the choices that you give. Yeah.
So, sir, like what's the mathematical reasoning that even if with such a small strength that is of 23, like now this is a case of 40.
I see. I understand your question. See, basically, you know, the mathematical reason is we are not actually 23, right? The number of ways in which two people can have same birthday in 23 is bigger than 23 choose 2, right? This number is quite big. This number is, if you do, I don't know, 23 into 22 divided by 2. So 23 into 11.
253.
Yeah, so that is why this is a quite a big number. Okay, so this number is what is mattering. It is not the 23 that is mattering so much, because you know the number of ways in which people can have the same birthday, that is quite a large number. Does that answer your question?
Yes, sir.
Yeah. So now you can see this number is close to 0.89. Okay, so that is what is expected. So this is it. This is all you need to do. Okay, so now if I want, let me do basically how to get samples from Poisson, how to get samples from normal in the remainder of the time. Okay, so let's do that. So before that, are there any questions in the midterm? So do you think you have got fair marks and in midterm? So let me ask that to the students. In the midterm programming, now that I have explained how things are coming, do you think you have got fair marks? So can you just say yes or no? And yeah, just based on what I have told you now, what do you think? Yes, can I have a quick poll? See, if you don't feel like you don't get fair marks, please approach me. I will help you. We will go through it together and I will explain what actually needs to be done. Okay. So this is what you should get comfortable with, this numerical aspects, right? NumPy, SciPy, you will find that they will be used everywhere. So for those of you who are bad at programming, what I suggest is in the holidays, you go through the probability things and try to see how you can solve some of the questions through sampling. Okay, and try to do some of these things. Try to go in internet and find what are all the exercises that you can do with NumPy. You can actually do linear algebra things. You can do a lot of interesting things that you can do in NumPy and just get comfortable with it. Okay, and when you come to machine learning, when you go to deep learning, all these Python things will be very useful. Okay, so this is probably the most useful thing that you are learning from this course. So it will take time. So don't get very disheartened if you don't do well in the midterm part, in the programming thing and all. Later on, it will help you. So this is like a bitter medicine that you need to have now so that you have a better career in the future. Okay, so every 0 that you get here will be a 0 in your salary at the end. So treat it that way and don't be very sad. All right, so that's here. So let me just continue in this discussion. Okay, so for the EndSem, what I'm thinking is that I will ask you all, the questions will be based on whatever I have asked you in the midsem, whatever I have asked you in the programming assignments. So I will restrict questions related to that. So if you have understood all the midsem questions, if you have understood all the programming questions, I will make a formal announcement. If you have learned all the programming questions that I have given in assignment 4 and assignment 2, I think. So if you have understood all of that, you should be good. So I will ask questions based on that. And I will also give you some options. So there will be one difficult question which may not be from whatever I have discussed, but other questions will be directly a variation of what has been asked. Okay, so that's what I'm planning to do. Siddhant, so does that answer your question?
Yes, sir. Thank you, sir.
All right, so this is it. So let's now try to do how to get samples from normal and things like that. So let's do that few things so that you get a little more comfortable. See, even I'm telling you, even I don't know directly how to get samples from normal. So I will have to look at NumPy and see. So, and NumPy samples from normal distribution. Okay, so if you just pick up that thing, it will tell you what to do. So you have to give mu and sigma. Okay, so that's how you get samples. So as simple as that. So what do you do? Normal samples is np.random.normal. Okay, the mean will be, let us say I will choose 12. Okay, variation will be the scaling is sigma itself. So you have to see what it says. Scale is the standard deviation, okay, not the variance. So variance square, the square root of variance. So let's say 2. Okay, and let's say I draw 1000 samples. Okay, and just to show whether this actually is correct, so we will plot the histogram. Okay, and let us say we fix 50 bins. So you see it is centered around 12, and this is how it looks. So this is how you sample from normal. Now, next, how do you sample from Poisson? Sample from Poisson distribution Python. Okay, so again, you will see that here you are giving lambda, okay, and size. That's it. So let us say there is a store where it is governed by a Poisson process where lambda is equal to one customer per hour, or maybe let us see 1 customer per hour. So let us say I want to see for 24 hours how many customers, how the customer's arrival will happen. So I will say Poisson samples. Okay, I will say np.random.poisson. Okay, and lambda is equal to 1, and how many samples? 24 hours I want. Okay, so this is if I do, and if I just look at the samples. So this is how customers will come. So sometimes one customer will come, sometimes no customer will come. Sometimes there will be 3 customers. So like this. So this is Poisson samples. Okay, now there is one more thing I may have to do. Sometimes, I don't know. I don't know now. If I look at this, I don't know when the first customer arrived. Okay, when the second customer arrived. So for that, I will need to do exponential, right? So do you remember this? So basically, if I do Poisson, I will not be able to tell where the customers are. So in order to tell where the customers are, I need to be able to pick customers one after the other at what times they come in, and each inter-arrival time is a exponential distribution. So let me just explain how to do that. So let us say, let's fix lambda, a little bit more interesting value I will choose. So lambda is one customer every 10 minutes. Okay, so 1/10, one customer every 10 minutes. Okay, so now if I choose Poisson samples for 24-hour things, so 24 hours I need to convert into minutes. Okay, so if I see the Poisson samples, this will show me how each minute how many customers have come, but it doesn't tell me at what times they came. Okay, so if I need to tell what times the customers come, I need to do.
Sir, you haven't used the value of lambda. You have used 1.
Yeah, sorry. Thank you. So we have to use lambda here. Thank you. So lambda, we have to be careful. So lambda has a special meaning. So let us say lambda. Yeah, okay. I didn't put the B, luckily. Okay, lambda has given. Okay, anyway, so if I see this, it will show me how every minute the customer has come. Okay. So since every minute there is only a 1/10 rate is 1/10, every minute it is 0 more or less. But if you collect across all the 24 hours, the minutes, you will see actually there are many more customers. And now if I need to simulate what time each customer arrives, I have to do exponential sample. So let me show you how to pick from exponential. So np.random.exponential example. So if you see, it says like this. So scale, what are the parameters? It accepts a scale parameters. Okay, so scale, if you look at the density function, scale is 1/lambda. Okay, so first thing what I need to do is I have to do scale, which is 1/lambda. Okay, and then I will say first inter-customer arrival time. Okay, is going to be, I'm going to ask just one after the other how many customers have come, their inter-arrival times. So what I will do, np.random.exponential. Okay, so scale. Now how many customers will come in 24 hours? I don't know. Let me simulate for 10,000 people and see what times they arrive. Okay, so now if you see, the first customer came in 1.2 minutes. So after 1.2 minutes, the first customer has come. Now the second customer, what time does he come? After 10 minutes after the first customer. So the second customer is actually coming at 11.20. Okay, the third customer will come at 22 point something, like that. Do you understand? So now if you want to get actual times, so there is something called as a cumulative sum. So that we will do np dot cumulative sum, okay, of inter-customer arrival times. So now if you see get actual times, so the first customer came in 1 minute, the second customer came in 12 minutes because there is E is here. So 12 minutes, the third customer came after 23 minutes. Okay. So now this is how you will simulate customers so that you know exactly at what time each customer has come. So we have seen how to simulate exponential. You have seen how to simulate Bernoulli choices. You have seen how to do normal. You have seen now how to do Poisson process. Is everything clear so far? Does anyone have any questions? Can I just have a quick poll again? So I will upload this in YouTube anyway, as before. You can experiment with this, but Is there any questions here so far? Is everything clear? Yes, can I have a quick poll? Okay, looks like people are having some questions. So please ask me if you are not comfortable. Perhaps you can go through the YouTube video and then you can see if there are any questions before the quiz tomorrow. You can ask me. All right. Is that a good plan? Okay, so let's do that then. So we will stop here. Are there functions for variance and expectation too? So there are. So if you give it a sample, it will tell you the expected value and such things are there. So you can search in Google NumPy variance expectation. Those things it will give you. Okay. All right, so I think we will stop here. I hope this discussion was useful. So tomorrow, maybe we will continue in the same line. I will try to give some more examples. And yeah, so that's what we will do tomorrow. Okay, so we will stop here. So yeah, so have a good lunch, everyone. Thank you.